Hi grade 9s. Today we're going to be learning about different types of chemical reactions, and today's just part 1, and we're going to be looking at synthesis and decomposition. There are other types of chemical reactions, single replacement, double replacement, and combustion, but we will get to those in a future lesson. So today we're just going to focus on the first two, synthesis and decomposition. Synthesis involves synthesizing or combining the combination of two substances to form a single product. So if you take a look at this diagram here, we have one thing plus another thing, and then here they're together. So for example, having hydrogen gas plus oxygen gas combined to form H2O or water. In the next example, I'm going to show you a video of someone who takes magnesium metal. It looks just like a regular strip of metal, and it's a little bit blurry here, and then putting it in the flame helps it react with oxygen, and it forms a new substance called magnesium oxide. We know that a chemical reaction has occurred because light is produced, and there's also a change of color at the end, and you'll see that it looks quite different. So I know it's a little bit blurry here. I'm going to hit play, but I'm actually going to skip ahead to 116 and then just give you a warning. I know this is a video, so it's, but we still have to kind of protect your eyes. It will get really bright, so I suggest kind of not looking directly at the screen, but looking off to the side a bit. And he did say that in the warning, but I wanted to skip his whole explanation because it was a bit long. And so we'll just watch
again,
this. Look off to the side for a little bit.
Burning of magnesium. And now I can release it, and you can see how it just crumbles. And we have some magnesium oxide. That's why the crucible tongues, the tips are now white. Magnesium oxide is a very soft white substance.
So you'll notice here that it does look different than at the beginning. At the beginning, it just looked like a strip of regular metal, and now it turned that white kind of ashy substance. So we know that something new has been produced, and it's magnesium oxide. Let's take a look at the equation for this. And so our observations here is when it created a really bright white light, and later it kind of formed this like ashy substance that was this magnesium oxide. If we wanted to write an equation, the word equation was magnesium plus oxygen gas react to produce magnesium oxide. Magnesium is a metal, so we would just write it as Mg for the symbol for magnesium. Oxygen gas is one of the Hofbrinkels, so I would write it as O2. And then magnesium oxide, if we wanted to write the formula, we would figure out that looking at the periodic table, magnesium is the second column, so it's 2 plus, and oxygen is in the 16th column, which means it's 2 minus. And so here, we don't need to use the crisscross method, it's just MgO. And then our second step would be to go take our skeleton equation, and I've added these in red. There are coefficients to balance everything. So making sure we have 2 magnesiums on each side and 2 oxygens on each side. But this 2 takes care of it because it applies to both. So that would be our balanced chemical equation for the demo that we just saw in the video. And we have 2 substances combined to form a new substance, so it's synthesis. Our next example is going to be decomposition, and this is just the opposite of synthesis. So this involves the separation or breaking down of compounds into individual parts. Our general equation is going to be just the opposite. AB yields A plus B. An example could be taking water, in this case, H2O, and separating it into hydrogen gas and oxygen gas. It is quite simple, and if you have a 9-volt battery and some push pins, you might be able to try it at home. If not, we're just going to watch the video together and we can see what they do here. You can also do this experiment without the test tubes, but you won't be able to collect
In that small plastic container are 2 metal push pins, and they're inserted a distance that's between the positive and negative lead of the 9-volt battery. So you just insert them in there and make sure that they're that distance apart, and that should be fine. In the container is going to be some water that has baking soda mixed into it. The baking soda in the water allows electricity to flow between the 2 metal tips of the push pins. And so now you set them on the leads, and the electricity can flow between the 2 push pins now. And so electricity is flowing through the water, and so that's enough energy to break apart the water, make it undergo a chemical reaction, so that the H2O gets broken apart into H2 and O2. It's going to be hydrogen gas and oxygen gas. And both gases are going to flow up through the test tubes, and one of the gases is going to be in one test tube, and the other one's going to be in the other one. How do you know which one's which? Well, if you take a look at the amount of gas in each test tube, it's going to be twice as much hydrogen gas as oxygen gas. So you can see in the right test tube, you have twice as much hydrogen gas as oxygen gas. This is how experimenters first learned that the ratio of hydrogen atoms to oxygen atoms in water is 2 to 1. It's 2 to 1 ratio, thus H2O.
He's going to do the same experiment again, but this time add a chemical that changes colors
Now
with
there's another way you can show
acids
water undergoing
and
electrolysis.
bases.
You can take the same 9-volt battery, hook up 2 wires to it, and then the end of the 2 wires you attach either brass wires or copper wires. I don't think it really matters too much. Then you put the 2 wires into a solution of bromothymol blue, and in the bromothymol blue solution is also some salt, so you can get the electricity flowing through the water much easier. And you can see electricity is flowing between the 2 wires, and you have bubbles forming, so that's the oxygen and hydrogen gas forming. Now one of the leads is going to produce a different color. There's going to be a chemical reaction happen. So the yellow color indicates that hydrogen ions are being produced, and that's becoming more acidic because bromothymol blue solution turns to yellowish and green when there's a higher amount of acid. There's more hydrogen ions. So again, this indicates that, again, there's 2 different chemicals being made, hydrogen and oxygen gas.
And so here we were just separating, he was separating hydrogen and oxygen from water. And so that's the general equation again. Observations, we're able to note that we have hydrogen and oxygen gas being formed. And because we have more hydrogen in the water, there's 2 versus 1, 2 to 1 ratio. We were able to notice that through the 2 electrodes of the battery, there was twice the amount of hydrogen being produced versus oxygen. So that was something that we would observe. And then for the balanced equation, just making sure that we have the same amount of hydrogens on the reactants in the products and the same amount of oxygens on the reactants in the products. So those coefficients here help us balance it. For today, I would like you to be able to practice this a little bit. And so we're going to look at this Phet simulation, and I'll work through the introduction with you and then just review what I would like you to do for the game. And then you'll have 2 options for today's assignment. So let's just go through the intro together first. So for our first one, we have to make ammonia, which would be synthesis. I'm going to use some of the tools here. It's really up to you if you want to use these. I personally kind of like this one because it's easy for me to visualize everything. I'm going to add 1 of each. So 1 molecule of nitrogen, it's one of the Hofbrinkel, so there's 2. 1 of the hydrogen molecules and 1 ammonia molecule. And you'll notice here that we're not balanced. And so in order to balance it, I'm going to see if I can add another ammonia. I'm still not balanced. Now our nitrogens are balanced. Let's try to balance our hydrogen. So to go from 2 to 6, I can say 2 times 3 is 6, and we're balanced. So this is a synthesis reaction and balancing. Let's try a decomposition reaction with water. I know we did this already. So with water, let's just add 1 of each first. And just to show you what it looks like with the balance beam, if that's helpful for you, here you can see it's not balanced because we have 2 and 2 and 1 and 2. Let's add another hydrogen here. And then let's add another water here, like we did in the previous notes from last week. And now we're balanced. We will get to combustion eventually, so I'm going to leave that for now. I wanted to get to the game portion. For the game, I would like all of you to go through level 1. It will give you 5 randomly selected questions to go through, and then if you click on this, it won't show you the products. If you click here, it'll show you each piece. So if it's helpful for you to have them, I find it helpful to have the visuals. So just do level 1 as practice, and then if you want to do the Screencastify Submit option, you can use Screencastify Submit to record your screen, and then it's up to you. You don't have to talk if you don't want to. If you just want to record today, this is going to be your balancing lesson, and there's just 5 random questions I'll have you do, and that's just from level 2. If you don't want to do that option, you could also just record a video of yourself showing how you work through the steps and showing all of your work for balancing 5 questions from your previous homework. So once again, option 1 is to go through level 2 and create a Screencastify video of level 2, just showing the 5 random questions and working them out. Option 2 is just to take a look at your homework from last week. You can choose any 5 balancing equation questions and then just show all of the work step by step, having the table where you balance everything. So here I have the answers, but I haven't shown my work. So I would like you to do crisscross method and then have a table with reactants and products, just like we did in the notes, and having all your work shown out for 5 of them. So those are your 2 options. Let me know if you have any questions.